This is Lesson 3-6, Solving Compound Inequalities. You do not have to copy this information to your paper. Just watch and follow along. A compound sentence is a sentence that joins two independent clauses with a conjunction such as and or. A compound inequality results when two simple inequalities are combined into one statement. You see the examples following. We have two simple inequalities combined together. You will need to copy this information to your paper. The set notation for an and an or compound inequality look different than what we've been doing so far. For an and compound inequality, the set notation will be the set of all x's such that we'll have a number is less than or equal to x is less than or equal to our number. You'll be able to follow this format for all and compound inequalities. Sketch this graph on your paper. An and compound inequality will always graph to where it's shaded to the inside. This would be like saying, I'm going to have a burger and fries for dinner. You're going to have both, so everything's included. The set notation for an or looks different. Copy this to your paper. We have the set of all x's such that x is less than or equal to our number, or x is greater than or equal to our number. Notice the graph. It is shaded to the outside for an or compound inequality. Also copy these to your notes. All numbers in set notations are listed least to greatest. Also, the graph will have open circles for less than and greater than symbols. You see in our example, we have closed circles because it says it's equal to. But it will have open circles for just a less than or greater than symbol. Pause the video at this time if you need to continue copying this information. Let's look at example 1. We're going to solve the compound inequality and graph the solutions. Also check. Copy to your paper. 12x minus 22 is less than 50 is less than 30x minus 10. This is a and compound inequality. Many times with and compound inequalities, you will not see the word and. You will need to rewrite it so that you can write the word and in between the inequalities. So that is step 1. Write your two inequalities. The first inequality is 12x minus 22 is less than 50. It's everything until you get to that second inequality symbol to make your first inequality. Then write the word and the second inequality. That would be 50 is less than 30x minus 10. Again, it is everything in the second part just after that first inequality symbol. We're now going to solve the inequalities. For the first one, we'll need to add 22 to both sides. Then we have 12x is less than 72. Next, divide by 12. Here we find that x is less than 6. Then solve the second inequality. We're going to add 10 to both sides. So we have 60 is less than 30x. And then divide by 30. You should find that solution to be 2 is less than x. Wait on flipping any inequalities around. If you need to do so to graph, feel free to do so. However, for our set notation, sometimes our number needs to go first. Look at your set notation for an and. The set notation for an and will always look this way. We have the set of all x's such that we'll put in our number is less than x is less than we'll put in our number. Remember, our numbers need to be least to greatest. So 2 is the smallest number. It will go in our set notation first, and notice how the symbol matches what we have in our answer. It is pointing to the 2, so in our set notation it still will point to the 2. Finally, the x is less than 6 will go in our set notation. The numbers must be least to greatest in set notation. If you do this correctly, it will always follow the format of an and set notation. We will now graph these on a number line. Do one less than your smallest and one greater than your largest. If you need to skip count while making your number lines, feel free to do so. 2 and 6 are not far apart from one another, so we can show every value. Now is when you may want to switch around the inequality. We solved that 2 was less than x, but to graph it by looking at the arrow, remember we learned that our variable must be on the left. So if you need to flip this around to know how to graph it, feel free to do so. It is an open circle on the 2, and just draw an arrow to show which way you should shade. To keep from messing up and have to erase your shading, if you will just use those arrows to make sure it shades as you expect it to. And then as you see, it does shade to the inside, so we'll shade our number line where they overlap. Do not shade past the 2 on the left or the 6 on the right, because we only want the area that they overlap. An and compound inequality would shade to the inside. Let's look at a Venn diagram for this solution. You do not have to copy this information to your paper. Notice oval A represents integers less than 6, and oval B represents integers greater than 2. The part that they overlap is the solution for this problem. To finish example 1, we'll need a check. You will check a number from the shaded region. So that means you could check with 3, 4, or 5. Always check in the original problem. I'm choosing to use the 4. You'll work out each part for your check. So do 12 times 4 minus 22. Work that out. 50, there's nothing to work out. And then finally work out 30 times 4 minus 10. We see when we work out each part, we find that 26 is less than 50 is less than 110. This is a true check, so we've solved and graphed correctly. Example number 2. Copy this to your notebook paper. We have negative 3 is less than x plus 1 is less than 2. Again, this is an and compound inequality. Our first step is to write the two inequalities. Be very careful, some students misunderstand and try and separate the inequalities in the center. That would be incorrect. Go all the way to the inequality symbol to make your first inequality. So negative 3 is less than x plus 1 is our first inequality, and x plus 1 is less than 2. We'll now solve each of the inequalities. Subtract 1 on both sides. We get -4 is less than x. For the second inequality, we'll also need to subtract 1. X is less than 1. Follow your format for an and set notation. Notice our numbers will be least to greatest, so our smaller number is -4. When we put that in our set notation, the arrow is pointing the direction it needs to. It needs to point towards the -4, and when it goes in our set notation, it will still be pointing to the -4. And then the 1 is our greater number, so it will be here on the right of our set notation. We will now graph this on a number line. Do 1 less than your smallest and 1 greater than your largest. If ever the numbers are too far apart to make a nice short number line, feel free to skip count. Here we'll have an open circle on -4. -4 is less than x. So if you need to flip this around to make it where the variable's on the left, x is greater than -4 to know which direction you should shade. It is an open circle. I advise for you just drawing an arrow for the time being before you shade your number line, so that you can make sure it shades as you expect it to do so. For the x is less than 1, it again is an open circle and we shade towards the less than side. This will shade as we expect on the inside of our number line. We'll now check a number from the shaded region. Always use the original problem when checking. I've chosen to check with a -2. You could pick any number from the shaded region. The only part we need to work out is -2 plus 1. We see that -3 is less than -1, and -1 is less than 2. So this does check out. Our solution and graph is correct. Example number 3. 3x is less than or equal to -12, or 3x is greater than 9. This is an OR compound inequality. Step 1 says to write the two inequalities. You are not required to recopy them. You can begin at step 2, solving. For the first inequality, we'll need to divide by 3. Notice there is a negative in our problem, however, we will not flip the direction of our inequality symbol. It's only when you multiply or divide by a negative, and we have divided by a positive. So we get x is less than or equal to -4. For the second inequality, you will also divide by 3. We find our solution is x is greater than 3. Now follow the format for an OR set notation. Is the set of all x's such that our variable goes first for an OR compound inequality? Put your numbers least to greatest, so the -4 will go first. Notice for the -4, we need to have the equals to line. So put that in your set notation, less than or equal to with that -4. and then x is greater than 3 is our larger number. Set notation always is least to greatest. Now we will graph it on a number line. We have x is less than or equal to -4. Remember, extra mark, make it dark. We have that equals to extra mark, so we make a dark solid circle. It says we should set shade to the less than side. Again, just draw your arrows to make sure that it is going to shade as you expect it to do so. You will need to go back and shade your number line once you see that it's doing as you expect. Here on the other side of our number line, we have x is greater than 3. That would be an open circle and shaded towards the greater than side. An OR compound inequality does shade to the outside, so shade those indicated areas. Finally, we'll need to check a number from our shaded region. Because we have 2 shaded regions, we will need to do 2 checks. Before we do so, let's look at a diagram of these solutions. You do not have to copy this to your paper. Notice in the circle for A that indicates less than or equal to -4, and circle B indicates greater than 3. There will be no numbers that can overlap in this solution. That's why our number lines will shade to the outside. So now for our check. We have 2 areas of the graph shaded, so we will need to check both areas of the graph. Always be especially careful when checking an OR. Whichever area of the graph the shading came from is where you need to check it in your problem. So this shaded region came from the 3x is less than or equal to -12. So check a solution from that area of the problem. When we work it out, we get -15 is less than or equal to -12. So that portion of the graph is correct. Next, the x is greater than 3 came from the second part of our inequality. So check a solution from that portion of the problem. For an OR compound inequality, you must always show 2 checks. Example number 4. Example number 4. We have 2t minus 3 is greater than 11, or 2t plus 7 is less than 3. This is an OR compound inequality. You will always see the word OR when working with OR compound inequalities. Pause the video at this time to try this example on your own. Let's check our solutions. You should have added 3 to both sides of the left inequality. We have 2t is greater than 14. You then will divide by 2. So first we find our solution t is greater than 7. Now subtract 7 on both sides of the second inequality. We have 2t is less than -4. We'll now divide by a +2. We will not flip the direction of the sign because we are dividing by a positive. Check your answers and correct anything you did incorrectly. Now let's check your set notation. Should be the set of all t's such that t is less than. You'll put your smaller number first, or t is greater than, put your larger number. If you follow this format, your answers should fit in each time. Notice for our smaller number, it says t is less than -2. That fits right into our set notation. Then t is greater than 7, again, fits right into our set notation. So list your numbers least to greatest. We'll now check a solution, or we'll now graph our solutions on a number line. Notice I did choose to skip count. I'm still showing a marking for every number. However, I skip count, only showing every other number. Feel free to do so when necessary when making your number lines. We have an open circle on -2, and we shade towards the less than side. And we have an open circle on 7, and again we shade toward the greater than side. This will shade as we expect it to do so. An or will always shade to the outside. Finally, we will check a solution from the shaded region. Because we have 2 shaded areas, we'll need to have two checks. Be very careful. Whichever area of the graph the solution came from is where you need to check your solution. So the 2t minus 3 is greater than 11 resulted in the solution t is greater than 7. So check a number in that portion of the inequality. We see that this does check out. 2 times 8 minus 3 gives us 13, and that is greater than 11. So for our second check, we will check a number from the shaded region, and 2t plus 7 is less than 3. When you work it out, we find that 1 is less than 3, so that is correct. For an or compound inequality, you should always have 2 checks. Example number 5. We have 8 is less than or equal to 3x plus 5 is less than or equal to 17. This is an and compound inequality. Be very careful with setting up your 2 inequalities. Pause the video at this time to write your 2 inequalities. Let's check to see how you did writing your 2 inequalities. The first one should be 8 is less than or equal to 3x plus 5. Be especially careful. You do not just cut the inequality in half. Go all the way to the second inequality symbol. To make your first inequality, it's 8 is less than or equal to 3x plus 5. And 3x plus 5 is less than or equal to 17. Pause the video now to solve these on your own. Let's check your answers. You should have subtracted 5 on both sides. 3 is less than or equal to 3x. And then divide by 3. You find your solution 1 is less than or equal to x. Remember, you may want to leave your solution with the variable on the right so that it can correctly fit into our set notation. If it helps you to flip it around for graphing, feel free to do so. For the second inequality, again you'll subtract 5 and then divide by 3. So we get x is less than or equal to 4. Follow the format for set notation. We'll need to put our numbers in least to greatest. So 1 is less than or equal to x is less than or equal to 4. Now graph your solutions on your number line. Do one less than your smallest and one greater than your largest. This is where it may be helpful to flip around your inequality symbol in order to put your variable on the left. because you can look at the way the arrow is pointing only when your variable is on the left. We're going to shade towards the greater than side of 1 with a closed circle. And we're going to shade less than 4 again with a closed circle. These should be equals to. 1 is less than or equal to x. X is greater than or equal to 1. Notice for our number line, it does shade to the inside as we expect it to do so. Finally, we will check a number from our shaded region. We only have one shaded region, so you're just responsible for one check. Always check in the original problem. Work out each part. The 8, there's no work required. 3 times 2 plus 5, you'll need to simplify. And the 17, there's no work required. So 3 times 2 plus 5 gives us 11. And this does check out. 8 is less than or equal to 11. And 11 is less than or equal to 17. Example number 6. The pH level of a popular shampoo is between 6.0 and 6.5 inclusive. Write a compound inequality to show the pH levels of this shampoo. Graph the solutions. We will use the ACE format to answer this problem. Inclusive means to include the stated limits or extremes in the consideration. So here we're asked to write a compound inequality and graph the solution. So for our answer statement, we will say the compound inequality is, the graph is. And we'll come back and complete that when we find our answer. To cite your text, we need to know that the pH level of the shampoo is between 6.0 and 6.5 inclusive. There will not be much work required for this problem, so we can just do an explanation to get to our answer. Let P represent the pH level. Inclusive means to include or equal. Always explain your thinking, so because we were given the word inclusive, we need to explain what that means. Inclusive means to include or make equal. Between 6.0 and 6.5, this would be an AND compound inequality. Notice we have the equals to marks because of it saying inclusive. So for our compound inequality, we will say the set of all p's such that 6.0 is less than or equal to p is less than or equal to 6.5. The graph of this solution, I've chosen to count by tenths. You have closed circles on 6.0 and 6.5, and it does shade to the inside as an AND compound inequality should. This concludes Lesson 3-6, Solving Compound Inequalities.